Hello everyone, this is a video lecture for Calculus 1, section 5.4, indefinite integrals. So what's the difference between indefinite and definite integrals? The plus C. Basically, so in the past, we've probably had a lot more of something like this here. So you'd add 1 to the power, divide by the new power, and then you'd start plugging in numbers and having a great old time doing it. That's 27 over 3. I'm just making something up, but apparently it's like a legit number here. 26 over 3. I don't think it's reducible. So that's what we've been doing. Now what we're going to do is say the same thing, and we go plus C. Isn't that so much quicker? So that's at least the idea. I don't think that's actually happening every single time, because the first problem, the second problem, the third problem, the fourth problem. Okay, all the first 4 problems have nothing to do with that. And then we have 2 problems that do, and then we go right back to not. So I don't think these sections are titled correctly. Honestly. So let's just do a recap on integrals. So first off, let's just say we were actually looking for this thing right here. And so I have my graph is x squared, something kind of like this. And I want to find the area from 1 to 3. I'm going to have to go a little higher here, I guess. And so the area from 1 to 3, there you go. So the integral is the area under the curve, area underneath the curve. I'll even write that up because it's so important. Area under the curve. Okay. Cool. So sometimes there's negatives. What if I had something like find this area? Well, that would be a negative area. We don't really have a negative area, but it will be a negative answer, and so you'd have to indicate it being negative somehow. I think that's about it. So let's just start doing some of these problems, because that's what we're gonna do. So 5, 4, 0, 3, 9. They say find the integral from 0 to 1 of x times the cube root of x, 2 times the cube root of x, and then 7 times the 4th root of x dx. Now this is just wild. For one thing, it is a definite integral because we have definite limits. So again, going contradictory to the actual section itself. But that's fine. I like doing these problems. It's a very good problem to do. Notice that this is actually a 1/3 power, and this is a 1 power, and it's a 1/4 power. So I'm going to take the 1 power and distribute it. And so what you actually get will be a 2, and now that's 1/3 plus 1 is 4/3. And it is perfectly reasonable. And then again, that's 1/4 plus 1 is 5/4. Perfectly reasonable to write your answers, your integrals, like this. This is very good. This is how you should do it. So that you could say, add 1 to the power and divide by a new power. So when you add 1 to this, you actually get a 7 over 3. And when you add 1 to this, you get a 9 over 4. And then we'd say plus C, if this was an indefinite integral. Sadly, not. And so we have to go and plug in the 1s and the 0s, and that's actually pretty simple. Plugging in a 1 makes those x's go away. Plugging in a 0 makes the whole thing go to 0, so you actually don't have to worry about that. I'm going to call it 3/7 in the front because I'm technically flipping it up into the numerator here. Calculator, 250 over 63. And that's it. So let's keep going. 5, 4, 0, 4, 6. I've got integral 0 to 2 pi over 3 of 3 sine theta plus 3 sine theta tangent squared theta all over secant squared theta d theta. this is an integral. So let's pause for a second here. I think that we talked about the integral antiderivative of the sine and the cosine already. I hinted at the secants and tangents and stuff like that. Yeah, this one's a monster problem. What I would rather see is have us write everything in terms of sine and cosine, okay? Apparently, I see what I'm doing here, and I don't like it. It's okay. Okay, so write everything in terms of sine and cosine, and so that tangent turns into sine squared over cosine squared, and in the bottom we got 1 over cosine squared. Okay. I'm going to flip this into the numerator, and so in each one of them, well, each one of these gets the cosine squared. And then we got over here. Now, this is getting a little crowded, but it will work. There. There we go. Cancel. Combine. Actually, you know what? Don't combine. I can factor out a 3 to the front. That's at least something. And so then I've got a sine cosine squared. And then we got a sine and a sine squared. Okay. Now, I know you're tempted to go and combine these guys. I was too. But really, I'm seeing something bigger. Is that I can factor a sine out to the front. Now, not to the front, not with the 3. That's like really, really in the front. But I just want to factor out a sine, and so that I can see this pattern that I know I've seen before. What is this equal to right here? It's equal to 1. Sine squared, cosine squared, Pythagorean identity, and all that kind of stuff. Look at that. Aren't you happy that you paid attention to all those trig identities back in pre-calculus? Oh, yes. Indeed. And this is very easy to do now. I'm going to remind you. So, I don't want that theta in there. So, sine, cosine, negative sine, negative cosine. When we're taking derivatives, we go down the chain. That's derivatives. For integrals, we go up the chain and then back down if we have to. And so sine, I go up. Of course, I have to start back over. And the answer is going to be a negative cosine. So negative 3 cosine theta. Now, again, plus c, but not really. Did you notice something? I left my limits of the integral off. I should have included them all the way down. Gosh, I'm just such a bad teacher. No, I did that on purpose. And so the reason why I did that was to show you quicker tricks to be able to get this stuff done without having to go through every single piece. In fact, I was highly tempted to just remove the thetas entirely because you could do all of this math without any thetas. Like right here. Did you see me include theta? You don't need thetas. It's okay. You could just write it later. So that's a perfectly legitimate way of doing it, at least in my eyes. I know technically you're supposed to keep doing it every time, but oh well. You have me as your teacher today, so there you go. I plug in the 2 pi over 3. I plug in the 0, which actually yields something. Notice, again, you're going to subtract these two. 2 negatives make a positive. So that's 120 degrees. The cosine there is going to be a negative 1/2. And then that's a negative 3. So stuff's going to cancel here in a second. And then we got over here, that's going to be a 1. So that's 3/2 plus 3, which you can just leave it like that, I guess. 9/2. I was also verifying that I actually got the right answer. I mean, sometimes I get it wrong. It's okay. Another one. From 0 to 1 over the square root of 3 of 2 times t squared minus 1 all over t to the 4th minus 1 dt. I'm telling you, these are some tough problems. Like, I just like to send this off to my Cal2 folks and see what they can do. It's a tough problem. It really is. That's good, though. I'm happy to see this stuff. This is where we're actually learning the integrals. I'm going to factor the top. I'm going to factor the bottom as well, but be kind of careful when I do this, okay? Notice that it's the same style, but with the 4, you got squares instead. And you know what's interesting is that I didn't have to factor the top, but I guess in the end it's okay. Do you see something funny there? Yeah, do you see something funny there? You seeing something funny? Cancel, 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 cancel. Gotta remember that 2 up there. I'm sorry, the 1. 2 could be up there, I guess, but there you go. All right. And pause. So we're going from 0 to 1 over square root 3. That's interesting. And I'm wanting to know what the next step is going to be. And guess what? IDK. Yep, exactly. That is one tough little thing there. So there are moments where you have to memorize things in order to get it more efficiently and, well, just to be able to do it at all. Some things in life are just memorized, and that's okay. Not often, not always, especially in math land. But say like quadratic formula. You're not deriving quadratic formula, not proving quadratic formula every time. You just know the formula, you plug it in, call it a day. Same thing here. We need a formula, and what this actually ends up being, I'm just going to give you the hint here. This ends up being an arctangent. Isn't that so nifty? Did you see that one coming? So arctangent is basically this integral right here. It's 1 over t squared plus 1 or x squared plus 1, something like that. It's a formula, and that's okay. So now you're learning. Now, I do need to plug these guys in. So 2 arctan of 1 over the square root of 3, 2 arctan of 0. If you're familiar with arctan, that goes away because arctan of 0 is 0. You can use your calculator, of course. If you really don't like using calculator, which I'm going to ask you why, but besides that, you could set this up as a fraction that we're more familiar with on a unit circle, saying that this right here is the tangent, thus y value over x value. So my y value is small, my x value is kind of big, and they're both positive, meaning quadrant 1, I'm guessing 30 degrees. Yeah, they're not going to like that. Pi over 6. Yeah, they're going to like that. These cancel to make a pi over 3 in the end, and there is your answer. Wow, that was so cool. It really was, actually. 54072. So this one is a little picky. They're asking for some stuff, and we've got to figure out what that stuff is. Let me just go ahead and write up all what they have here and then interpret it for you. Because I would normally ask you in class, what does this mean? But you're just watching a recording. And that's okay. That's why I'm making these recordings. So anyways, they have the acceleration, and we want the velocity. You can see velocity. We have the initial velocity. That's what this is in particular. And then we have a time frame to do it. So in order to go from acceleration to velocity, guess what? We are taking an integral. Oh my goodness. And so I'm going to integrate this 2t plus the 4 dt. Now, they say it's 0 to 3. Correct? Hold on. Hold on to that thought, okay? Let's integrate this first. So I've got 2t squared over 2. can add 1 to the power, divide by new power. Here we got a t to the 0, so then you just add a t to the 1, divide by 1. You'll soon get these tricks that a constant goes to a linear term and all that kind of stuff. And I'm going to do a plus c here. Now, this is kind of strange. What we're doing is not as intuitive. I was really going to start putting this guy in there. But what we've gotten at this point is a formula. And if you noticed here, v of t is a formula. So we actually did not want to plug in the 0 to 3. That would have given me a complete total velocity something or other. Not what we're looking for. They want a formula. So in order to find out what c is, we're going to plug this stuff in. And notice this is going to be a t value, and that's going to be my v value. And this is v right here. This is your answer. So v is equal to t squared plus 4t plus c. And so then we have negative 5 is equal to 0 squared plus 4 times 0 plus c. Cancel, cancel. C equals negative 5. And so my answer is t squared plus 4t and then minus the 5. Ta-da! So what was the 0 to 3 business? What is this? Well, that's part B. That's right. We need to go and find the total distance. So total distance. Let's start over. So acceleration, I integrate, and I get my velocity. I'm going to integrate again to get my distance. And so that's what we're going to find here. So I'm going to actually integrate 0 to 3 of t squared plus 4t minus the 5 dt. And you go through all the process, which I'm not going to show you, and that does not work. I went and tried to do it and plug it in, and it was not working in WebAssign. What are they wanting? What are they wanting here? Well, if you remember that we can have a negative area, and that's when it's scary. Let me graph this thing for you. Let's just factor it right quick. This is t plus 5, t minus 1. Yes, so then we got plus 5. Sorry, I don't know why I didn't write that. Anyways, positive 5 makes it, that's t equals negative 5, 1, 2, 3, 4, 5, and a positive 1. And we have this parabola that does this thing. Now, they're wanting the total area from 0 to 3. 0, that's a 1. There's a 2. There's a 3. And so I'm trying to find all this area here. And then all this here. Can you see something? We got a problem, don't we? I have a positive area here, which is good, but I have a negative area there. If I were to integrate this strictly 0 to 3, what's going to happen is that you have the positive and the negative start canceling each other out a little bit. So you don't get your true answer. What we actually want is we want to find what this is and find what this is and then put them together, add them together, make them both positive together. And so there's a couple ways you can do this. I recommend just doing them separately. 0 to 1 of t squared plus 4t minus the 5 and 1 to 3 of the same thing. Now, you already know how we're going to get this, so let me just do the math. Cubed over 3, squared over 2, negative 5t from 0 to 1, and basically we'll be getting the same thing over here. Okay. When I plug in the 1, I get, well, fractions and stuff. When you plug in the 0, you get 0. So what you actually end up with here is a negative 8/3. The thing is that we know we don't want it to be a negative. We want it to be a positive, okay? That's a distance traveled. And then here, we're going to do the same thing and plug in all those numbers. It'll be a lot bigger. I'm going to make that a 2 if that's okay with you. Thanks. So all this stuff here minus, and then I plug in the 1, which should give me those fraction actions. Why did I put a half here? This is a 2. I'm very sorry. That's a 2. I'm sorry. It's still the 8/3. I'm sorry. I messed up right there. That was my bad. Always watch to the end. Yeah. I mean, I make mistakes just as much as anybody else. And so from here, let me flip the page and see what I got. I got 44/3. So what I want to do is add these together, and then you're done. I want to make a small analogy as to why we're doing it like this. So just give me 1 second. This is a 52/3. Okay, so there's your final answer right there. That's your total distance. Okay. So what's going on here with my parabola is that I have some positive and some negative, right? And so they want the total distance. Well, think of the negative stuff as like going in reverse. And so let's say I have my car. That's a super awesome car. And I'm like, oh, wait, hold on. I forgot that thing at home. And then I back up. And then I grab the thing. I jump out of the car, grab it, and I say, okay, now let's go. And I go this way, right? Now, I'm not asking because I don't really know how cars work, but what would be the how much total distance has been read on the car? When you reverse, does the tick marks thing go backwards? I can't even remember the name is. An odometer? Is that what it is? I think it's an odometer. I don't know. Just tachometer? So there's all these other cool ometers. It's not a speedometer. So anyways, we're moving backwards. Cool. And then we go this way. So let's say we went backwards 1 mile, but then we went forwards 4 miles, right? And so how much total distance really did you drive today? Was actually 5 miles. It was not 3 miles. Do you see kind of what I'm going with here? Even if you went in reverse and then you had to go forward, in the end, how much did you actually travel? That's the reasoning behind it. 54012. We got integral of u to the 5th minus 6u to the 4 minus u squared. They skipped a thing there. And then 2/9 du. And that is it. There's nothing else to do here. It actually is your first indefinite integral. Woohoo! Yeah! We actually don't have to do the entire problem all of the time. So, and that's a good thing for us. Add 1 to the power, divide by the new power for like all of them. And because you don't have a u, go ahead and just put a u in there. Plus c, and you are done. That is it. That is the end of that problem. Isn't that so cool? Then I got 4x squared plus 7 plus 2 over x squared plus 1 dx. And they say, go ahead and figure this one out. Look, it's another indefinite integral. I love these things because I don't have to keep on plugging things in at the end. Plus, they're letting us just do it. They're finally just letting us go. We can finally do whatever we want. And so let's figure this thing out. I'm going to add 1 to the power. Divide by the new power. 7. He's going to get an x. And this guy, have you seen that one before? Come on, I'm waiting. 5, 4, 3, 2, 1. This is arctangent. That's an arctangent. So you put the 2 in the front. Arctan. And then, again, plus c. That's it. The end. And if only all of your problems were like that. Sadly not. Because we're right back at definite integrals down. Oh, actually, no, we got another indefinite. Okay, cool. They give us 3. Oh, my goodness. And then, yeah, we'll go right back to the definite integrals. But that's okay. That's okay. We're going to live it up while we can. Now, that's 3 times all this stuff. All right, tell me, what's the first step? Yep, move the 3 out. That was an awesome idea. That was so cool. No, yeah, seriously though, what's the next step? Come on. And no, it's not divide the signs out and That would be funny. Not at all. Is there some kind of trig formula for this guy? I would say out of all of the trig formulas, the trig identities, this is one of the very few that I actually have memorized. So it's 2 sine times cosine. And the sines will cancel. The 2 can come out. Now we have a 6 in the front. Cosine of x dx. Forgot the dx. Not that lazy. And so I want to integrate. And if you remember the chain, I'm not going to write it every time. Remember the chain. Go back, go back, go back. It's a sine x. And that's a 6 in the front. You say plus c, and you're done. That was it. Whew, I love that. All right, now we're back at the definite integrals again. 0 to square root 3 over 2 dr divided by the square root of 1 minus r squared. What? Weren't you just as confused whenever I gave you the arc tangent formula? And so the same thing here. This is just a formula, and I will say that it is one that I have barely, if not at all, memorized. It's arc sine. It's arc sine. And again, there is a lot of formulas that I have memorized because I'm a math teacher. This one, this is a borderline one. I might have remembered it. Maybe not. And so that's the purpose behind writing these formulas down, using them, and you will be using them again later in Cal2 for sure. They do come up again. Arc tangent a bit more than arc sine, I'd say. So my y value is bigger, therefore 60 degrees. Well, you know what they want. Pi over 3. And arc sine of 0 is going to be a 0. Again, you could test all this stuff out in a calculator, but there you go. Another thing that you might be seeing is that I use arc sine instead of the little -1 thing, and that's totally fine. They're both the same. They're both the same. I intermix them actually a lot more than you think. I've just been on an arc, arc for the past while, I guess. I don't know. But the -1 is equally important because that's probably the one that your calculator will look like. If you're doing Desmo Scientific, I believe you can type arc sine just like this. And on WebAssign, you can certainly type the long version out. Okay. I wouldn't use it if we couldn't actually use it. Rate of r of t equal to 400 minus 8t. We're going from 0 to 50, and it says find the amount after 30 minutes. You ever wonder if someone's giving you too much information? Especially in a math problem, right? This 0 to 50 business is too much information. They say find the amount after 30 minutes. We're going to go from 0 to 30 of this stuff. And so then we got 400t, 8t squared over 2 from 0 to 30. So plugging in the 30, that's going to be a 4 in the front. Plugging the 0 would basically just yield a 0, so you don't really have to do anything about that. Calculator for sure, and 8,400. There you go. And I think this is actually the last question of this section. So C prime of x is equal to 3 minus 0.01x. Oh, whoa. Plus 0.0, oh my goodness. 0.0006x squared. And they want the marginal cost. What? And this is exactly why I do these problems here on the recording, because, I mean, just frankly, it's just confusing without knowing what they're actually asking for. That's really, I'd say, the purpose of this is to know how to approach these strange problems. So what are they wanting? Here. And they say find Oh, okay, so that is the marginal cost. This is the marginal cost. Find the cost from 2,000 to 4,000. Okay, that's what they're actually looking for. Well, I mean, it's not hard. 2,000 to 4,000, integral of all this stuff here. 1, 2, 3, 4, 5. I think there's 5 up there. Whew. It is very hard to count all those zeros. My notes, apparently I just said, oh, well, the answer is this. And that's okay. Do you know how to just go ahead and just get the answer? Oh, I can't say it on a recording, you know. There's definitely options out there to just get it. But I do recommend going through these problems by hand so that you're practiced on it. Because guess what? You're going to be doing these same problems in Calculus 2, Calculus 3, and onwards for sure, okay? Now is the perfect time to study that stuff. All right. I'm actually pleased that that section went so well. And although they lied to us about the indefinite integral stuff, at least we didn't have to do all that other stuff we had been doing. Thank you very much. Have a great day.